Hello, everyone. Welcome back to day 2 of week 2. Last time we left off on this slide and we worked on a string demo and a little bit of review about some operators. So I just really want to quickly note that escape characters are in between our quotation marks, and you have to use 2 equal signs when you're testing for equality. And this stands for not equal. So this is when you're testing whether 2 of the things that you're testing are not equal to each other. If so, then you would conduct all of the code inside the brackets. So you usually use this within if statements. Okay, so that wraps up a bit of review on that. I strongly recommend you guys to watch last time's video and review the end of it where we talked about each and one of these scenarios. And that's pretty much it for that part. Today, let's talk about more notes on string comparisons. So in the past, we have used the 2 equal signs, the not equals, and the not equal to symbol. And we've also sort of talked about how you can do comparisons with the less than equal to sign and the greater than and the greater than equal to sign. So we'll do a quick review on those as well. But the new thing to note is that you can use something called and or symbols to actually help with multiple comparisons. So if you're checking for 2 ints being equal to each other and for 2 strings to be equal to each other, then you would use this and. For another scenario might be if you're using 2 strings to see if they're equal to each other or you want to see if 2 doubles are not equal to each other, you'd use this. So the main thing is this is like the joint symbol you can use. So again, to reiterate what we just talked about, these 2 symbols are used when we have multiple different things that we want to compare within one if statement, for example. So when we do these comparisons, we can actually compare them with strings. So we know that A is less than B. I mean, that sort of does make sense since B would have a larger number. And you might be thinking, okay, what number does A and B correspond to when you are doing these conversions and these calculations? So we use something called the ASCII chart. So basically, when you are working with these operators, they compare strings character by character. And when you do these comparisons, you have to remember that these are case sensitive. So if you look at the last one, for example, the only difference between this apple and this apple is the fact that the first letter is uppercase here and the first letter is lowercase here in the second comparison. So these 2 are actually going to be different when you do these comparisons. They won't be the same. They all have different values. So the ASCII value for the letter A, for example, is 65 and comes before the lowercase a, which is 97. So when you're working with this, you look at like the decimal value of these ASCII charts. So we'll just really quickly check out this chart. What I will do is I will escape and I'll show you guys the chart right here. So we have 65 is our A value, 97 is our lowercase a value. So you can see that as you increase in the language, in the just the English language, you can see that the decimal values are increasing. And we're using these decimal values when we are working with these conversions or these calculations to check that A truly is less than B. And then this first letter A is less than that lowercase a. So in a case where you have more letters, like help has 4 letters and hello has 5 letters, generally you have to take a look at each and every symbol. So HEL, the first 3 letters are pretty much the same. They're going to be the same ASCII value. Then you have to look at P, and then you have to look at L. And again, you look at all these comparisons by the ASCII value, character by character. Okay, so the last one is strange, and we already talked about why it is with the ASCII values being different for each letter, even though the only difference here is just the lowercase and uppercase thing. But you have to remember that any uppercase letter will be smaller when you look at, oh, yeah, this will sound confusing, but any uppercase letter whose ASCII value, whoever's in regards to the ASCII value, it'll be smaller when you compare it to the lowercase ASCII value. I know it's like a mind boggler there. Yeah, when I was saying that sentence, I myself got confused, but you just have to remember that the lowercase ones have a bigger ASCII value, and be sure to look at this chart whenever you have any doubt. Okay, so that's pretty much it on string comparisons. Now on appending, we talked about this last time. We can directly add two strings, S1 and S2. Similarly, if you want to use in another way to add them, you can use the append function. So to do that, you just do dot append parentheses semicolon. And then of course, in front of all of that, you would have your variables, and you would have it in the correct order of what it would want you to do. So string 1 dot append, string 2, basically. So you can use the append operation there. But there's this new operator and this new type of calculations we can do using plus equals, minus equals, division equals, multiplication equals to do any sort of calculations. Specifically, you can use plus equals to add two strings together or add a string and a character together. So let's just really quickly try that. So just to remind you guys, when we are working with strings, it's important to just have the string library there, just so you guys know what you're dealing with. Oh, perfect. Okay. And then you can just copy all this notes that we did, and again, store it at the bottom. Make a comment. Okay. So we are going to first start off with just adding strings using this new operator that we haven't talked about yet. So I'm going to add the string A, B, C, but of course I have to name it something. String S1 is A, B, C's, and this is the correct order of declaring that string. And then I'm going to add a string called S2, and I'll just call it DEF. So of course I want all this to print out like A, B, C, D, F. Specifically, I want string 1 to equal the contents of string 1 and string 2. So let's go ahead and try that out. What I'm going to do is, oh, by the way, I just want to show you a quick little error. So if I did string S1 is equal to anything, I'm just going to call it ACD, for example. There's one error here. You cannot redeclare that S1 is a string if you've already done it once. Remember, anytime you work with C++ or with this variable again and again, you're going to just call it string 1. You don't have to keep on saying string, string, string every time. So I'm just going to say string 1 is equal to ACD, but that's not exactly what I want to do. What I want to do is I want to add the contents of string 1, which is just, string 1 plus the contents of string 2. So this is something we kind of showed earlier, but there is an alternative to that as well. So I will show you guys both. So this is our first one. Yep, so it does everything as intended. It just makes string 1 A, B, C, D, E, F now, which is perfect. But there's this different thing you can do. There's this other notation where you can simply put S1 plus equals S2. So, oh, S1, my bad. So when we were doing this, we were basically saying the new S1 is equal to the old S1 plus S2, whatever was in S2. So we just added on more to it. Here, we're basically doing the same thing. We're just saying, okay, you're just going to add this new thing of S2. If I don't have this plus sign there, you're just going to make string 1 equal DEF. So let's just really quickly try that. So S1 equals S2 is just going to print out DEF. Exactly. So we need that plus there to just say, okay, we're going to still have our S1 information, but we're just going to add S2 behind that. And that does what is intended as well. So this is how we would work with that using strings, for example. Now, what if I tried using ints? So you can actually do this for ints as well. So int x is 10. So I'm going to do x equals x minus 5. And I'm just going to do cout statements every time so we know what we're dealing with. So this should make it just be 10 minus 5, which is 5. So I'm going to really quickly do another change here. Now I'm going to say x times equals 3. So it's basically doing the same thing as we did last time. So if our new value of x is 5, 5 is just going to be multiplied by 3. So it's just our x multiplied by this value. So when we're doing this, we're almost just ignoring that equal sign when you think about it. Your x is just being multiplied by whatever is on this side. So then we would get what? 15 here. So I would basically say 5 times 3 is 15. And that's how that one would work. Okay, perfect. So right here we have 5, right? Because that's 10. So our new x is our old x, which is 10 minus 5. So that's 5. So x is now 5. At this point, x is now 5. Now then we couted it. Yep, it is exactly 5. Now we just want to multiply our x and times 3. So that's why we get 15 here. Sometimes it might get confusing, but it's nice when you just break it down line by line, and then you can really understand it. Also, another operation you can use instead of x equals, actually, I'll just really quickly delete this. So there's this neat thing where if you want to do x equals x plus 1, let's just first cout it so you guys know what this does. So if you want to do x equals x plus 1, you know it's just going to be x is 11 because it was 10 originally. We're just adding 1. That's perfectly fine. But there's another shortcut. You can simply just do x plus plus, and this just increments it by 1. And this only works if you want to add by 1. So you can actually do something similar where you do x minus minus. And then our x minus minus would actually lead it to be 9. But actually, before delving into x minus minus, I just want to show you guys this, and let's see what would happen. Perfect. So what we're doing is just incrementing it, and you can also do plus plus x. So if you were to do plus plus x, let us see. It would also just tell you 11. The difference with plus plus x and x plus plus, it's just x plus plus is doing it post, is incrementing the value post incrementation wise. This is working on everything pre-incrementation wise. So that is just something the compiler looks at, but for now you don't need to know a ton about that. But just know you can always use x plus plus or x minus minus if you want to increment by 1 or decrement by 1. So this case, we're just going to decrement, which is decrease. It should just be 9 now. Perfect. Okay, that is pretty much it for that part. Now, what I'm going to do is I'm going to show you guys a quick example about using the AND operators and the OR operators. So let's just really quickly work on that. So if, let's just say I want to check if our X is greater than 0, and I want to check if X is less than 10. So originally what we would do if we didn't have this operator is we would have multiple if statements embedded within each other. So we want to check that X is greater than 0 and X is less than 11. So that is just how this if statement would work if you want to just have multiple if statements and check for multiple different things. But this can be a lot, you know, we just want a shorter way to just add all the multiple different if statements we want to check in order to print out a specific value. So we want our X to also be not equal to 3 then. Let's just say these are all of our conditions, and then we would execute some code. And by the way, you can execute code here as well, just like code, any code. But the main thing is this scenario is basically testing for multiple different if statements and conditions, but we just want to clean this up essentially. So that's why we would use something called the AND operator. So how I would clean that up is pretty simple, actually. I would just keep the parentheses there and the conditions there and just combine everything by AND. So if my X is greater than 0 and it's less than 10 and it's not equal to 3, then I want to execute the code. And remember your parentheses match. You don't want extra parentheses or anything like that. And remember, you need to have equal parentheses on both sides. And for each condition, it has to be enclosed in parentheses. And of course, the entire if statement needs to be enclosed in parentheses. So this is the entire if statement enclosed in parentheses. This is one condition, another condition, the third condition. And it's all enclosed in parentheses. Okay, perfect. So we're going to execute the code. We're just going to see out perfect. And this will only happen if we fulfill every single one of these conditions. So if I want to do that, okay, perfect. So our X is 10, right? Which means it's greater than 0. And it's less than 11, so it's perfect. And it's not equal to 3, which is great. What if I said, okay, this time our X is 3. This time, even though it is greater than 0, it's not fulfilling this, but it is fulfilling this. So it's not fulfilling one of these scenarios. Let's see what would happen. Nothing would get printed because it would not execute this code. This code would only be executed as long as all conditions are true. In this case, one of our conditions is false, so none of this will happen. But if we wanted to, if we didn't really care about all of these conditions being met and only one of them being met, I could simply change this to be an OR. So this is the OR. So in programming, this is our and this is our OR operator. So this is OR. In this case, not all of these conditions have to be fulfilled, just one of them. So in this case, 3 should work, even though 3 is not equal to 3 is giving us a false thing, it should still execute this code. Perfect, because at least one of these conditions are being met. And as soon as the compiler sees, okay, one of these are met and it's OR, it doesn't care. It's like, okay, I'm just going to execute all this code. So that includes all of our knowledge about the operators and using all of these operations, including the pluses and the minuses. So I hope that part helped. Now let's get back to where we left off. So we already shared the demo about adding strings. Hopefully you guys know about all of these 3 ways to add strings now. Now we're going to talk about a more complex string function, which is insert. So remember, dot insert parentheses and a semicolon, and remember having the variable name there is just the format we use whenever we're calling any pre-built string function. So it's really easy for us in the end, because in the end we just have to call this function and it will do the magic of inserting a specific string into that specific string's position. So insert would insert, in this case, this operation inserts string 2 at the position start. So position is the same thing as index. It's going to be int within our string 1, and it's just going to shift everything over. That can be a little confusing, but I made this nice little graphic for you guys to understand that. Right now we have this original string, which is string 1, which is right here. It's called Oven's Pizza. Doesn't make sense right now, right? But what I'm going to do to make it make sense is I'm just going to say ovens for pizza. So it's a weird little phrase to say, but that's just the phrase we've come up with for now. So 4 is the string that we want to insert. And we want to insert it between the S and the P for ovens and pizza. So what we're going to do is we're going to move this string to be inserted at index 4. So it's going to be inserted right here. So we have string 1, ovens pizza, dot insert, and we have our index right here, which is start. And we have string 2, which is 4. So you might be thinking, what's going to be happening to this side? It's all just going to be moved over. And whatever index we're moving a string at, that index is exactly where the new string will start, and everything else will just be moved over. So you can ignore the size, but I just made these little lines to just make you think that they're all character by character. So remember, strings are just made up of different characters. After insertion, remember our 4 would be starting at right here at this index. So we have 0, 1, 2, 3, 4. So ovens, and then we have 4 pizza. So at 4, we want to add it there, which is exactly what we're doing. So we just finished ovens, and we just added it right there. Okay, so that's pretty much it for insert, for example. And replace. That is a cool little demo we're going to do. Actually, we're going to do a demo with both insert and both replace. But before that, let's just talk about replace real quick. So replace is going to do a similar thing where it's going to remove from string 1 a total length of characters starting at the position start, and it'll replace them with the copy of string 2. Okay, let's go ahead and try all of this out. Okay, so what we have right now is this assignment where I want all of us to just check or filter specific words. So in the Zoom chat, for example, let's just say I'm a programmer. I want to add this functionality or this one thing, this one new update where no one can say any bad words. So what we're going to do is we're going to replace the word poop, for example. We'll just pretend it's our bad word for now. We'll replace our bad word poop with just some symbols, just like this, to filter them out. That is an example of what we're going to do there. So I'm just going to call this string a caption, and we're going to get this caption from our user. So what we're going to do is we're going to use getLine. I hope you guys remember that from last time. So getLine allows us to get spaces as well when we're adding, when we're taking in a specific variable's input from using sin. So getLine, sin, cin, caption. So we're just going to take in spaces. So I can put like, I love poop. It's a strange example, but that's something we're going to use right now. Okay, perfect. So we're just going to getLine this caption, and we are going to find the index of it using this getLine. So in real life, a person can say pizza, poop, Legos. I'll just say this is their caption in the chat filter or something. So what we're going to do is we're going to filter this out. But I don't want to look through every single thing, every single character, and check whether or not the word poop is there. So what I'm going to do is I'm going to use this function that strings already have. It's called the .find function. And that way you can find certain characters and certain strings or part of a string of the specific caption. So I'm going to call this int index of questionable words. So I'll just call it index. So int index is equal to our caption dot find, and we're going to find poop there. So in our world, let's just pretend poop is just a bad word. We just don't want it to be there in our chat or whatever. So we're going to try to filter it out. So regardless of what the user says, we're going to try to filter out that word poop and just put that there. So what we just did is we found the index of where this word would start. So now what I'm going to do is I'm going to introduce something called while loops, which you guys will learn about next time as well. But this is just a little unit for you guys to work on, or just a little activity for you guys to work on after next week's lesson. I just really want to introduce this .find function and that next project for you guys. So you're going to use a while loop, and I need you guys to print out the specific index and replace the index and replace the word at that index with the asterisk. So this is something you guys will talk about next week. Not this specific example, but I really want you guys to do this mini project on your own. So this is your very first mini project assignment to work on your own. You can email us if you need help, but in the end, you're going to look at a while loop. You'll print out the index. You'll replace the word at that index with the asterisk. And then after successfully replacing that, you'll keep on finding and searching for that word. Actually, to make life easier, you can change poop to just be something crazy like pizza. Let's just say pizza is a bad word. That'll be pretty crazy, but let's just imagine that in this case. Okay, so replace any given word with this. That's your main task. You can think of it like you're filtering someone. That's your mini project. And in this while loop, we're basically, you don't really have to use a while loop. You can use anything, but you're going to do more of this next week. Well, you'll print out the index, you'll replace it, and you'll keep on finding or searching for the word. And I'd like you to eventually see out the new caption using what you did earlier with replace. So this is a really cool assignment. I'm really looking forward to seeing what everyone comes up with. Please email us if you have any questions and if you want us to take a look at your code. but this will probably just be an at-home assignment since next week we'll delve into other activities. So this is just something to remember. Okay. So while you guys work on that, let's talk about another example of replace. I really wanted to demo that as well. So let's go ahead and do that. But in addition to that, let's also work on using .at versus index to help us find a value of a specific position in that string. And we want to show you the two uppercase and the two lowercase functions that are there. I think there's a little typo here. There should not be a P. Let's go ahead and try those out. So this is a cool little project for you guys to work on your own. Okay. So while we're back to this, let's just say I have a sentence and I said, coding is hard. Well, that is just a sentence that we have there and we can see out this sentence. But in the end, let's just say I want to add a word in between is and hard. We can just do coding is kind of hard. Coding is a little bit hard, just as an example. So what we're trying to do here is we're going to insert the phrase kind of or sort of. We can do kind of, sort of, anything. Sort of at a given position, which we're trying to find first in this sentence. Okay, so we'll probably need to do something like sentence dot insert a specific thing at that specific index. So we have an index there and we have the string of what we want to say. So in this case, we just want to say, what was it? Sort of. Okay. So it'll look something like this. So what is our index going to be? Let's see. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So at index 8, we want to add sort of. So that is precisely what we will do. We can easily go ahead and try that out. And if the index is off, we can play around with it and understand where we would have to edit that. So let's just do sentence dot insert at index 8. We want to add sort of there, just as an example. And then I would like to just print out this sentence just to see what we have there. Okay, let's try to do that again. Sometimes the Wi-Fi or the compiler just takes time. So we have this all there. Let's see. Yep. Hopefully this should not take too long. What I'll do actually is I'll just comment that out. Maybe we should just work on incremental programming. It seems like my compiler is just going a little bit berserk. So I'll just really quickly save all of this and I'll quickly refresh. Okay, let me just copy this again. Don't think we copied right. Yeah, sometimes you just have to wait for the compiler to fully load. And since this is an online compiler, we are working with Wi-Fi issues as well. Okay, perfect. So what I'll do is I'll actually just say out that. Okay, so right now, this is what we have. Coding is hard, and then we've inserted coding is sort of hard. You can tell there was a little bit of weird stuff going on there. So we might just see and play around with it a little bit and see what happens when we just put it at 9. Okay, it looks much better. Let's go ahead and see what the problem is with is and sort. So the thing is, we need to remember to count the spaces as a whole new thing. When we're counting for the index, we have to not forget about the spaces. So I've noticed here that is and hard already has a space, right? So I actually don't need the space right here. And now, again, you have to just play around with it and fully understand what can I edit, what can I fix. So we see that the main thing here is that there is a space after is, and what we have to do is we can either add a space here or play around with the index. And just for time's sake, I'm just going to add the space there. And by now you guys should see that, hey, you can easily insert stuff there as well. So that is one example of that. So that is pretty much it. If you want to do something with replace, we can also do that really quickly. Replace. So this time what we're going to do is we're going to replace specific index as a point. So we're going to place at index 7 just 2 characters, and they're going to be an asterisk, just to see where is it, or what specifically is it going to replace. So I'll just put something random there just to show you guys what would happen. Okay, so right now, coincidentally, 7 is referring to the I there. So I can replace is sort of hard to just say, okay, I'm gonna add 4 letters there, and instead of is, I'm just gonna say is int. And since we have that apostrophe there, I'm actually gonna say it's 5. That is the length of the characters that we're just replacing it with. So now we have coding isn't blank of hard. So as you can see, it sort of messed with the replacement there. So you have to be careful with that and make sure that you don't accidentally do anything crazy and delete half of a sentence. But for now, just remember you can do these 2 functions and you can play around with that some more. Okay. So for 2 uppercase, 2 lowercase, it's also just the same thing. We just have to do dot, 2 uppercase, dot, 2 lowercase, and then the whole string will be uppercase or lowercase respectively. So let's do another demo. Actually, today is just all about demos since we want to show you guys some practice with that. So this is probably going to be our last demo, but it's a really important one because it talks about libraries, which is something that we mentioned, especially with the strings, but I want to show you guys an example of where you can actually use math libraries to help with getting some of those math things out. So the math library I will use is actually called #include C math. Exactly. So this refers to getting the power of something, and it helps with that. It's very helpful. Okay. Let's go ahead and try that out. What we have right here in this first programming assignment is you can go ahead and pause it right here and try it on your own, but given 3 double data types, the X, Y, and Z, we want to output all of these. So go ahead and try that out. This is what we're going to do. So we'll have a double, that's an X, and we'll just call it double XYZ for now. Okay. So let's take in all of this from our user input. We can't use getLine. Remember, getLine refers to string. So what we're just going to use is cnx, and then I just continued this buffer here, which is just saying continue to ask for it 3 times for cnxyz. But this is the same thing if you were to do this and that. For now, you can just leave it that way. So we're taking all this from our user input, and what we want to see out is first the power of x to the power y. So we would use a POW function. So that is power. So that would give us the power of x to the power y. So for example, if x is 2 and y is 4, it would just give us 2 to the power 4 being counted. And then we also want to do a couple more things. So x to the power of y to the power of z. So we use parentheses for that. Let's just really quickly have a note of all of these. Okay, x to the power of y. Then we have all of these things to do. Actually, what we'll do is we'll just use endl just to make it prettier. Or if you want, you can actually put a space in between of these specific values that we're trying to output. And you can just put it all in one line. It's just something easier. So the second thing should also look like that. We're going to use the POW function. So we'll do x to the power of, this time we're going to use the POW function again, because we're doing x to the power of y to the z, which is exactly doing that. And then we want to do the absolute value of x. And to do that, we have to do this function. This is all thankfully provided by the math library. So the math library is amazing. It allows us to even get the square root of a specific thing. So this one is the square root of x, and the square root of x times y to the power of z. So that can be a bit confusing, but let's just break it up. So the square root of something to the power of z. So we want to multiply something. So we want to do x times y to the power of z, for example. But I'm going to obviously have to have a parentheses there for our x times y operation to conduct it first as well, just so it's separate and cleaner. And you can always add spaces just so everything's not like combined all in one. It can be a lot for the eyes too. Yeah, so this is exactly what we wanted to output, and I can just output a space between all of these, and we'll just print that out and see what will happen. Oh, actually we are having an error here. Let's just really quickly see what we messed up on. Oh, it's because we're missing a bracket. Thank you so much for letting us know, compiler. I absolutely love it when compilers are super smart and tell us where at least the little blurry area of where that error is happening. So that's wonderful. So I'm going to cn 2 or 3 values. So I'm going to put in 4. I'm going to put 5 in, and we'll put 8 in, or 8.3 in, for example. And yeah, so this is exactly the kind of thing that would have gotten outputted But in the end, let's just double check and do something easier so we aren't going a little crazy. Okay, so I'm going to input 2, 3, and 2 there. So yep, that is a bit more cleaner, and that's what I think we should work on for just first example, since you guys are just beginners. And actually by the end of this week, you'll probably be a lot more understanding of a lot of C++ code. So hopefully you guys understand this a bit more. It's been great teaching you guys, and starting next week, we have new mentors and coding bootcamp instructors to help you guys out. Thank you so much for watching, and feel free to leave any comments or suggestions down below. Thank you so much. Have a great day. See ya.